Assalamualaikum and good day, students. You who enrolled with this course, GEC104 with the course description, Mathematics in the Modern World. I'm one of the video lecturer for Chapter 3, which is Logic. For my colleague, Ms. Nurlaila Madid, had discussed already the previous topic of this chapter. This video lecture composed of the following. Part 1 with the topic Universal and Existential Statements, Quantifiers and Negation, and Conditional Statements. Part 2, which is the Derived Conditionals and Biconditional Statements. So sit back, students, ready your notes, for we will start in a few moments. A universal statement is defined as a statement that states a property that is true to all. So example of this are the following. All positive numbers are greater than 0. So it is true for all positive numbers that it is always greater than 0. For every even integer x is divisible by 2. So that is also true for every even integer x, it is always divisible by 2. Next, ang bawat isa ay may pag-asa. So this is also true for all. And ang lahat ng halaman ay nakakain. So all of these are universal statement that states a property that is always true to all. On the other hand, a statement which is state that there is at least one thing for which the property is true. So for instance, we have the following. There is a prime number that is even, and that number is 2. It is prime and at the same time even. There exists a number which is divisible by any number except itself. This is also true, and that number is a prime number. So another existential statement, mayroong isang tao sa mundo na nagmamahal sa iyo. So you know that there is at least one person in this world who love you. So number 4, mayroong isang mag-aaral sa MMW na hindi makakapasa. All of these are example of existential statement. The phrases there exist and for all plays a huge role in logic and logic statement. In fact, they are so much important that they have special name, and that name is quantifiers. So quantifiers, in other words, are expression or phrases that indicate that a statement pertains to. So in mathematical logic, there are two quantifiers, the existential quantifiers and universal quantifiers. Existential quantifiers are used as prefixes to assert the existence of something. So in symbol, we use this notation here to be read as for some x, there exists x such that, or there is some x such that, which is to represent existential quantifiers. On the other hand, in the statement, the words none, no, all, and every are called universal quantifiers. So the universal quantifiers none and no deny the existence of something. So whereas the universal quantifiers all and every are used to assert that every element of a given set satisfies some condition. So the symbolic representation of universal quantifiers is this one, to be read as for every x, for all x, for each x, or given any x. Example, determine the truth value in each of the following. Number 1, for all x element of this set containing 1, 2, and 3 such that x squared is less than 10. So if you are going to evaluate, so 1 squared equals 1, that is less than 10. 2 squared, which is equals 4, is also less than 10. And 3 squared is equals to 9, which is also less than 10. So for all x element of this set, this condition is satisfied. So the answer is true. Number 2, there exists x element of this set containing 10, 15, and 20 such that 3x plus 1 is odd. So we're just going to find an existence of x that will satisfy this condition. So suppose we will use 10. So 3 times 10, that is 30, plus 1, that is 31, and that is odd. Since this is existential statement, so the truth value is true. Number 3, for all x element of the set containing 1, 2, 3, such that x plus y is prime. So it should be that all the element here must satisfy in this condition since this is a universal statement. Suppose we will use 1 for x and 3 for y, so that is x plus y, so that is 1 plus 3 equals 4, and that is not a prime. So since this is universal, it makes this statement false. Number 4, there exists x element of the set containing 2, 4, 6 such that 2x minus 5 equals 5. So to make this statement true, this must be 5 so that it would equal to 5. So the answer is false since none in this set that will satisfy this condition. Unlike any other logic statements, we can also negate the universal and existential statements. So let's proceed to the negation of universal statements and existential statements. So for the universal statements, its negation is the existential statements such that not P. And on the existential statement, the negation is the universal statement such that not P. To help us easily negate any quantified statements, so the following table are useful. For universal statement, all x are y, the negation is some x are not y. Another universal statement, no x are y, and the negation is some x are y. For existential, some x are not y, the negation is all x are y. And some x are y, the negation is no x are y. Example, write the negation of each of the following statements. Number 1, some airports are open. So the negation is no airports are open. Number 2, all movies are worth the price of admission. And the negation is some movies are not worth the price of admission. Number 3, no odd numbers are divisible by 2. And the negation of that is some odd numbers are divisible by 2. Some students are not permitted to submit their research assignment. The negation of that one is all students are permitted to submit their research assignment. Another example, state the negation of the following sentences and determine the truth value of each negation. So this is the given. Number 1, for all x element of the set containing 0, 1, 2, 3, x cubed minus 1 is an odd integer. And the negation of this statement is, so there exists x element of the set containing 0, 1, 2, 3 such that x cubed minus 1 is an even integer. So take note of from add, the negation is even integer. To determine the truth value of this negation, we simply evaluate x cubed minus 1 at its given value of x. Since x cubed minus 1 is even when x equals 3, then the negation is a true statement. And number 2, there exists x and y element of the set containing -1, 0, and 1 such that x equals y plus 1. The negation of this statement is from existential to universal. So for all x element of the set containing -1, 0, and 1 such that x is not equal to y plus 1. To determine the truth value of the negation, we substitute the given values x and y in the expression x not equal to y plus 1. All values of x and y in this set must satisfy the condition such that this one, x not equal to y plus 1. Observe that when x equals 1 and y equals 0, it is false, and this condition is not satisfied. Therefore, the truth value of the negation is false. And number 3, there exists x element of the set containing -1, 0, and 1 such that x squared equals x. And the negation of this statement is from existential to universal statement. And the negation of this statement is for all x element of the set containing -1, 0, and 1 such that x squared is not equal to x. To evaluate the truth value of this negation, we simply evaluate x squared not equal to x at each given value of x. Since the negation of the given existential statement is true when x equals -1, therefore the truth value of the negation is false. Conditional statements can be written in if P then Q form or if P Q form. The P statement is called the antecedent while the Q statement is called the consequent. For example, identify the antecedent and consequent in the following statements. We have this given conditional statement. If our school was this nice, I would go there more than once a week. So the antecedent here is our school was this nice, and the consequent, I would rather go there more than once a week. Then number 2, kung mahal mo ako, mangangahulugang kailangan mo ako. So The antecedent here is this one, and the consequent is kailangan mo ako. So, number 3, if you strike me down, I shall become your powerful, more powerful than you can possibly imagine. So, the antecedent is you strike me down, and the consequent is I shall become more powerful than you can possibly imagine. And number 4, if 378 is divisible by 18, then 378 is divisible by 6. So the antecedent is 378 is divisible by 18, and the consequent is 378 is divisible by 6. And lastly, if x squared equals 9, then x is greater than 0. So the antecedent here is x squared equals 9, and the consequent is x is greater than 0. Every conditional statement can be stated in many equivalent forms, so it is not necessary to state the antecedent before the consequent. For instance, the conditional statement is if I live in Boston, then I must live in Massachusetts. It can be stated as I must live in Massachusetts if I live in Boston. So the following table lists some of the various forms that may be used to write a conditional statement. We have if P then Q, if PQ, P only if Q, P implies Q, not P or Q, every P is a Q, Q if P, Q provided that P is Q is necessary condition for P, and P is a sufficient condition for Q. Okay, for example, write each of the following in if P then Q form. The number is an even number provided that it is divisible by 2. So if in this form, if P then Q form, if it is divisible by 2, then the number is an even number. Today is Friday only if yesterday was Thursday. So it can be written as if today is Friday, then yesterday was Thursday. Jenny is not Alisa's sister, or Jisoo is Alisa's friend. So in if P then Q form, if Jenny is Lisa's sister, then Jisoo is Lisa's friend. Next, being born in Korea is necessary condition for being a citizen of Korea. So answer in if P then Q form, if you are a citizen of Korea, then you are born of Korea. The conditional statement if P then Q can be written using the arrow notation of this notation. So the arrow notation, this notation is read as if P then Q or as P implies Q. So we have here the truth table for P implies Q. So if P is true and Q is true, so P implies Q is true. If true implies false is false, false implies true is true, and false implies false is also true. Observe that the conditional statement P implies Q is true and only if the truth set of P is a subset of the truth set of Q. So that is why we have here false implies false is true. Example, determine the truth value of each of the following. Given the conditional statements, if 2 is an integer, then 2 is a rational number. Since P is true and Q is true, then the truth value is true. So true implies true, then true. Number 2, if 3 is a negative number, then 5 is greater than 7. So our antecedent is false, P is false, and Q is also false. So false, if false, then false, the truth values is true. Number 3, if 5 is greater than 3, then 2 plus 7 is 4. So our antecedent is true, but the consequent is false. This is not equal to 4. This is 9. So if P, then Q, our P is true, but Q is false. So the truth values is false. Number 4, if 4 is greater than or equal to 3, then 2 plus 5 equals 6. Observe that our antecedent is true, but the consequent is false. So true implies false is true. Number 5, if 23 and 27 are odd numbers, then these are not divisible by 2. Take note that our antecedent here is true and the consequent also is true. So true implies true, the truth value is true. The negation of conditional statement. We all know that conditional statements have equivalent forms, and one of these forms is not Q or P, which is written symbolically as not P or Q. This means that P implies Q is equivalent to not P or Q. It follows that the negation of P implies Q is equivalent to the negation of not P or Q, which is equals to, and by De Morgan laws, it can be expressed as P and not Q. So the negation of P implies Q is P and not Q. For example, write the negation of its conditional statement. If they pay me the money, I will sign the contract. So the negation of this conditional statement is they paid me the money and I did not sign the contract. Number 2, if the lines are parallel, then they do not intersect. The negation is the lines are parallel and they intersect. And number 3, if I finish the report, I will go to the concert. So the negation of this statement, I finished the report and I did not go the concert. So number 4, if the square of n is 25, then n is negative 5. So the negation of this statement is the square of n is 5, then n is not 5 and negative 5. That would be all for part 1. See you for the next video.